Welcome to lesson 322, adding and addition and subtraction equations. Today we're going to talk about how to use subtraction to solve addition equations and how to use addition to solve subtraction equations. Alright, so first you need to understand what the word inverse means. Inverse means the opposite. This is not in your vocabulary. This is just to help you out with the next piece. So if inverse means the opposite, then the inverse operation is operations that are opposite and undo each other. Alright, so the inverse operation, so if I have addition, the inverse is subtraction. If I have division, the inverse is multiplication. Alright, so we're going to use these to help us solve different types of equations. So you have to remember, what does the equal sign mean? We talked about this in the last lesson. The equal sign means that whatever is on this side of the equal sign has to be the same as what's on this side. So if that's not the case, it's not equal and we put a slash through the equal sign. Alright, so if I have 7 on this side, whatever x is, when you add it to 5, because this would be x and 5, whatever that x is, and the 5 together has to give you 7 because you have the equal sign here. Otherwise, it is not an equal equation. Right? And then logically, we know that, oh, well, I know if I add 2 to 5, that it is equal to 7. So now what's on this side is equal to what's on this side. Okay, we have to remember the golden rule of algebra. We've talked about this a lot with math. The golden rule of algebra is do to one side what you do to the other. This is really important when it comes to solving equations. Okay, so when you did the x plus 5 and it was equal to 7, logically we know that the x has to be 2, but we know that because we have number sense. And we know that if I do 7 minus 5, it'll give me 2. So you're actually doing what the equation wants you to do. So if I move that over here, I know I need to subtract 5, but what I do to one side I have to do to the other, because otherwise it's not balanced. And I know that I get 2 has to be x. The reason that works is because of the subtraction property of equality. The subtraction property of equality, and this is in your vocabulary section on the bottom, labeled properties. If you subtract the same number from each side of an equation, the two sides remain equal. Right? So when you are solving equations, you have to remember that if it's an addition equation, you want to use the inverse operation. So you want to use the opposite, so I'm going to use subtraction. And I want to get the variable by itself. So in order to get rid of everything but the variable, in order to get rid of addition, I use subtraction. Well, if I added 10, so if I went 10 steps forward, I would want to go 10 steps backwards, so I would want to subtract 10. But what I do to one side, I have to do to the other. Now I'm left with v, well, plus 10 minus 10 would be 0, so v plus 0 equals 49 minus 10 is 39. Oops, it should be a 9. Okay, and v plus 0, we know because of the 0 property, the identity property of addition is always going to be v, and so v has to be equal to 39. Right, I'll do one more with you. So in this case, we have 28 plus n equals 65. Well, I want to get rid of the 28, and since it's addition, I have to do subtraction. But what I do to one side, I have to do to the other. Here I'm left with 0 plus n. 65 minus 28, I borrow from the 6, carry the 10. 15 minus 8 is 7. 5 minus 2 is 3. 0 plus n is just going to leave us with n, and we have n is equal to 37. Alright, so I want you to try this one on your own, and when you come back, we'll go over your answer. So logically, you know that you would have to do minus 25 on both sides. Okay? And so you do that. Oops. Sorry about that. Okay, so you do that. And when you do that, you're left with 0 plus n equals 14. You know 0 plus n is always going to be n, so you know that n has to be equal to 14. Now you can always check your answer by actually putting the 14 back into the problem for the variable. I'm sorry, this was, make that an n. If you left it as p, that's fine. Okay. You can always go back and double check and say, okay, well, is 25 plus 14, does that give me 39? 5 and 4 is 9, 2 and 1 is 3, and it does give me 39, so n equaling 14 does work. Okay, so when we have addition equations, it's usually pretty simple for us. It makes sense because when you have plus 10 and minus 10, it's logical that the minus 10 gets rid of the 10. However, now we have subtraction equations, and this is where it tends to get a little bit complicated. You have to remember, it's like keeping the scale balanced. Okay, so if you're keeping the scale balanced, if you add 4 just to the right side, because you know that whatever x is, so if I have x minus 4 equals 1, I know that I have to add. So if I do 1 plus 4, then I get x minus 4 equals 1 plus 4. Now this side is too heavy because I didn't add 4 to this side. Okay, now I get x minus 4 equals 5. Well, I didn't get rid of the minus 4 on this side because I didn't do to this side what I did to this side. But if I add 4 to both sides, it keeps the equation balanced. So whereas before I just had x minus 4 and I had 1, you'll notice I added 4 to this side and then I added 4 to this side because I have to keep it balanced and do to one side what I do to the other. Now this is where it gets tricky. When you have a minus 4 and a plus 4, think of it like a board game. If you go backwards 4, so minus 4, and then you go forward 4, so plus 4, it gets you to the same spot that you're at. It gets you back to 0. So think about negatives. If we change the x minus 4 to x plus a negative 4, and then we have a negative 4 plus a positive 4, you know that those two are going to get each other to 0. So in this case, you're at x plus 0 equals 5. You know that x plus 0 is always x, so x is equal to 5. Okay, how does that work? The addition property of equality. It's the same thing as the subtraction property. However, now it's using addition. If you add the same number to each side of an equation, the two sides remain equal. Please remember to get that into your notes. All right, so we're going to try this. So we have y minus 23 equals 39. So we're going to add 23 to both sides. Okay, and then minus 23 or negative 23 plus positive 23 gets us to 0. Y minus 0 equals 9 plus 3 is 12. Carry the 1. 3 plus 2 is 5, plus 1 is 6. Y minus 0 is always going to be y is equal to 62. Again, you can double check. You can do 62 minus 23 and make sure that it equals 39. So 12 minus 3 is 9. 5 minus 2 is 3. So I know that I do have the correct answer. If you're getting confused on this part and you're coming up with 46, you have to remember this is like saying plus a negative. So if we're doing plus a negative, you want to get it back. You always want to get back to 0 when you're adding and subtracting. So negative 23 plus a positive 23 is going to get rid of that negative 23 for you. Or think of a number line. Okay, if you subtract 23, so if you start at 0, you subtract 23, you get to negative 23. Then if you add another 23, you get back to 0. So you always want to get back to 0. All right, we'll try this again. So here you have plus 15. What I do to one side, I have to do to the other. So here I have 13, carry the 1. 7 plus 1 is 8, plus 1 is 9. So 93 is equal to s minus 0. S minus 0 is always s, so 93 is equal to s. All right, I want you to go ahead and try this one on your own, and when you come back, we'll go over your answers. Alright, so in this case you would have added 3 to both sides, because the minus 3 and the plus 3 would take you back to 0. You would end up with z plus 0. I'm sorry, that should be a minus 0. There you go. Z minus 0 is equal to 15. So z is equal to 15, and then you can double check and see that 15 minus 3 does equal 12. Alright, so what I'd like you to do is there are a couple of problems that I'd like you to try on your own. There's an addition equation and a subtraction equation. If you have questions, because I know especially the subtraction ones are tricky, please make sure to post those questions to Edmodo so we can go over them in class.